My name is Scott Myers. I'm the product manager at SAPU Bioscience, and today I'm presenting on our PubMed corpus builder. Essentially, we aim to tackle three problems when it comes to traditional research. First is the actual search results. You either get too little or too many. Even just something super specific can return maybe 3 or 4 papers, and they just don't have what you're looking for. Number two, downloading the papers. There's no actual fast way to download papers from PubMed. And so we kind of aim to also solve that issue. And number three is filtering. There's no easy way to filter out these papers to find something even more specific that a traditional search result would not. And so that's why we developed our PubMed corpus builder, and this is essentially aimed to solve all three of those problems. I'm going to go into each of the solutions in depth, but this is what the interface looks like. Essentially, we have utilized chatbot technology. So if someone were building a chatbot from the documents automatically, they would put in the bot name, and under the select engine, they would choose the type of engine. The corpus name is a name for basically once all these documents are gathered, they're uploaded to what we use, AWS S3, and that would be the name under which they are stored. Your email address, so that way you can get the documents and stuff emailed to you, which I'll go into in a little bit. Your search query. This is kind of your broad search query for PubMed. And then your subfilter. Think of it as a prompt of like, I only want articles that contain blank. So you could put, say, tumor growth graphs or nanoparticle size less than 20 nanometers. And the number of IDs to download and number of queries. I'll explain that in the next slide. And then the subfilter method, I will also get into that in a little bit. Sorting, you can sort by date, by relevance, or both. And then email docs, which is if you want the actual PDFs emailed to you. So the first thing is searching the database. And so what we do is we actually first take your original search query, and in addition to that search query, based on the number of search queries that you selected, we use AI to generate multiple search queries, additional search queries. So you can see some of the original query here and some of the AI generated ones. And what we do with each of those queries, including the original search query, are turned into special PubMed search URLs, which is either, again, also by date or by relevance. And what that ends up returning is just a list of PubMed IDs that are the results for those search. And basically now, when there's the option for the top X a number of IDs. So in the original building, it said number of IDs. So if you chose 10, you're downloading the top 10 IDs for every search result. So now what you're doing is you're exposing yourselves to a significantly larger number of documents than had you just done the original search result. And the idea behind this is to cast a wide net to get all the documents in and for us to be able to subfilter them later. For example, how you are exposing yourself to such a high number of documents. Imagine you could set it to say top 50 IDs and 20 search queries, right? Sorting of both. Well, for the 50 queries 50 IDs, 20 queries, that is a maximum of 1,000 documents. However, if you sort by both date and relevance, you're doing it twice. So that's 2,000 documents. But then you have to add in the original search result for each one. So you're exposing yourself to a maximum, in that case, of 2,100 documents. But obviously, a lot of these search results are very similar. So you will have a lot of overlap. So despite being 2,100 search, like maximum search results, you'll probably be left with like 300 to 400. Obviously, depending on the original query, that could be more or much less. Now, how do we download the documents? Well, right now, we are only able to download documents off of PubMed Central because they're free. There are some websites that are external, but we don't support that yet. We did originally, when we first developed this, actually use the PubMed Central search engine. Uh, but we found that it was worse. It was actually really bad. It was much better to use PubMed, even and then use the PubMed Central articles. And so what we do is, because PubMed Central has some tools that are available for to download things, but they require your PubMed Central ID. Well, for now, we first have to convert PubMed ID to the PubMed Central, and then it generates this URL. Again, we're doing this for every single one of those IDs. And the PubMed URL returns an XML format similar to as you see here, where we then are able to extract it and then get the download link, which we then, it's technically a tar file, which is a converted file or a compressed file, and then we extract it from there. So now we have gone through the searching and the downloading. Now filtering. Now this is our kind of special sauce, as I like to put it. We have two sub-filter methods. The first is vector search. And essentially we are indexing the document to a vector store and querying it to try and determine as to whether or not whatever you put in your sub-filter query exists in the document. I'll give you a real example. Was we were looking for papers that only involve certain nanomedicines with nanoparticles under 20 nanometers. And so you would use the vector search method to get that. And it pulled out one really good paper that wasn't in the actual original search result. This was a search done by our CEO. And I took that same search result and the filter and I threw it into the PubMed corpus builder. And the paper that we found was not in the original search result. So by using this, we were able to find a paper that normally would not have been found. And then we have the multimodal method, which multimodal is all image based. And so, which makes it better to interpret charts and figures to try and determine, like, say, is there a certain type of graph or like a dot plot in this document? However, it would be super expensive and time consuming to send the entire document to the multimodal LLM because it would require us to convert the PDF to images, and some of the documents are well over 100 pages. So what we did was we did some programming to extract just the images from the PDF, just all the images from the PDF, so that will include the actual charts and graphs, and send those to the LLM to try and determine as to whether or not the particular piece of information is within the document. However, we find that utilizing, although obviously the method that you use for subfiltering can vary based on what you are looking for. Sometimes if it's very much just text based, if you're looking for something to be within the text, vector search seems to be the best way to go. But we also have the ability to combine both. And then what happens is after all that, all the remaining documents, so you're going from like 2000 2100 document potential to maybe down to 300, and depending on your sub filter, maybe 10 or 20, but those 10 or 20 are really good documents. And so after the documents are uploaded to our OneHub and S3, essentially, if you enable the bot to be built, it would automatically be built now. However, since it's uploaded to our system, a chatbot can be built later from it. It emails you the URLs to the documents, and if you have email docs on, it'll send you actual PDFs. So to conclude, we are essentially taking these, casting a wide net, and then filtering it down. And the entire goal, for the most part, is not only to streamline research, but to find documents you wouldn't normally find. And also to be able to use these documents in other ways. For example, another example, our CEO was trying to extract all this information across, I think it was like 300 documents, just abstracts, was looking for PK characteristics and stuff like that. And he was trying to use ChatGPT to do it. And it just wasn't working. So I used the PubMed corpus builder with his original search query, and I used the sub filter of it was like or PK characteristics or information about polymer, to try and make sure that the documents that I got back did include information that he was trying to build a table out of. And then we've developed our own our own table bot that is able to make CSVs out of documents. And so I was able to make one large CSV with all the information that he was looking for that ChatGPT just simply couldn't do. However, we are super excited for this technology. It is very new, and so we are constantly iterating on it. But the scientists in our company are already using it and have been saving them a ton of time.